start with what is Ethereum. Ethereum is a decentralized blockchain platform that enables smart contracts and decentralized applications, also known as dApps. Ethereum uses Ether or ETH as its native cryptocurrency. The Ethereum platform has many use cases. It can power different kinds of applications. In this demo, I'm going to create a decentralized voting application designed to be deployed on the Ethereum blockchain. To do this, I'm going to use the Solidity programming language. I'm going to do my development inside of Remix IDE, which is a web-based Solidity development environment for writing, compiling, deploying, and testing smart contracts on the Ethereum blockchain. So here I'm in the Remix IDE. I have my file explorer over here. I'm going to create a new file, voting.sol, and I'm going to use the Solidity programming language to create a contract. This voting app will serve as a decentralized voting system that allows users to vote for candidates and view results securely. Specifically, we'll have admins that are allowed to register candidates, we'll have users that are allowed to vote for candidates, 1 vote per user, and then we'll allow anyone to view candidates and vote counts, and then ultimately be able to retrieve the winner based on the highest votes. At the top of the file, I'm just going to specify the Solidity version. Then I'm going to define the contract. I'll start with the keyword contract. Name of the contract is voting. And then we'll have curly braces. And everything contained within the contract will be in between those curly braces. We'll start with the structure to represent a candidate. We'll use the struct keyword. I'll name the structure based on what it represents, candidate. Now we'll define the attributes of a candidate using variables. Every candidate will have a name, which is a string. And every candidate will have a vote count. This will be an unsigned integer. This is the number of votes the candidate received. Now we'll define a structure to represent a voter. Again, we'll start with the struct keyword. We'll name it voter. Now the attributes of a voter. The first one is has voted, which is going to store a Boolean value. This will store a true or false value indicating whether or not a given voter has voted. A voter can only vote once. And then every voter will have a voted candidate ID. This will be an unsigned integer, and it'll store the ID of the voted candidate. So the ID of the candidate that the voter voted for. Now we're going to define some variables inside of the contract. This will store the address of the contract admin or the deployer. The data type is address. It's public, so fully accessible. It's called admin. And now we're going to define a mapping to store voter details. This will track whether a particular address has voted. So I'll create a mapping address to a particular voter. Fully accessible. It's called voters. And then I'm going to create a dynamic array to store the list of candidates. An array is sort of like a list. So here's how we define an array of candidates. This is an array containing instances of the candidate structure, so an array of individual candidates. Now I'm going to create an event which will be triggered when a new candidate is registered. So when the admin adds a new candidate, this event will happen. The event keyword, it'll be called candidate registered. And it'll have a name, which is a string, and a candidate ID, which is an unsigned integer. Now I'm going to create another event. This will be triggered when a vote is cast. So when a vote is cast, this event will happen. Event keyword, it'll be called voted. It'll contain the voter address, which is also indexed. That just means it's stored in a special data structure in Ethereum. And then we'll have the candidate ID. That's the ID of the candidate that the voter is voting for. Now I'm going to create a modifier to restrict certain actions to only the admin. So this is a way of restricting particular functions so they can only be called by particular users. In this case, the admin. Keyword modifier. This modifier is called onlyAdmin. And this requires the sender or the caller of the function to be the admin. Here's the custom error message. Only admin can perform this action. And then we have the underscore semicolon. This is a special symbol that's used to indicate the end of the modifier and the beginning of the function that the modifier is modifying. Now I'm going to create another modifier to ensure a voter hasn't already voted. Keyword modifier, I'll call it has not voted. I'll place the requirement inside of the curly braces. I'll look up the given voter in the voters mapping. And this is going to require that the has voted attribute for that voter is not true. Basically, that the voter has never voted. Then I'll add that interesting underscore semicolon. Now I'm going to add a constructor function. This runs once when the entire contract is deployed. It's called constructor. And this sets the admin variable to the deployer of the contract. Assigns the deployer as the admin. Now I'll add some other functions to the contract. Keyword function. This will be called register candidate. This function will register a candidate. As an argument, it's going to take a string stored in temporary memory. It'll be the candidate's name. The function is fully accessible, and we're going to apply the only admin modifier. This will push to the candidates array, a new instance of the candidate structure. And this will pass a dictionary with the given candidate's name and the initial vote count of 0. We'll say add candidate to the array. The function is then going to emit the candidate registered event, given the name of the candidate, along with a unique index number for the candidate. Emit event for candidate registration. Then I'm going to come up here, I'm going to add documentation for the function. A function's documentation will appear between a / ** and a */. We'll add the documentation here within that block. I'll use the @dev annotation and describe the function at a high level. Allows the admin to register a new candidate. And then I'll use the @param annotation, the name of the argument, and then a description, the name of the candidate to be added. Let me fix this. This should actually be the keyword memory, which refers to temporary memory for that variable. Now I'm going to add another function keyword vote. This function will allow a user to vote for a candidate. As an argument, it'll take an unsigned integer. We'll call it candidate ID. Fully accessible. We'll apply the has not voted modifier. First, we're going to check that the given candidate ID actually exists. We'll do that with a require statement. As long as the given candidate ID is less than the length of the candidate's array, meaning the index exists in the array, otherwise the given error. Once we've ensured the candidate exists, we'll mark the voter as having voted and store their choice. Here we're going to place in the voter's mapping, based on the caller of the function, a new instance of the voter structure with the given dictionary, true value for the has voted key, and for the voted candidate ID key, the given candidate ID. Then we're going to increase the candidate's vote count because they were voted for. So I'll look up the candidate in the candidate's array. Given the candidate ID, I'll increment their vote count by 1. And then I'm going to emit the event for voting. So we're going to emit voted, given the caller of the function, and the given candidate ID. Then I'm going to add my function documentation. I'll go to the top of the function, / ****, ***. I'll add my documentation to this block. Description of the function allows a user to vote for a candidate. Parameter called candidate ID. And what is it? The ID of the candidate the user wants to vote for. The next function is going to fetch the details of a specific candidate. Function getCandidate takes an unsigned integer, which is the candidate ID. Fully accessible, returns a view which cannot be modified. In that view, we'll get the name of the candidate, which is stored in temporary memory, and the vote count for the candidate. We're first going to ensure that this is a valid candidate ID. We'll use our require statement. As long as the candidate ID exists as an index in the candidates array. Then we're going to create a candidate variable. It'll be stored in persistent storage. Using the given candidate ID, we'll look up the candidate in the candidates array. And then we're going to return the name and the vote count for that candidate. We'll add the documentation for our function. Here's our block. This fetches the details of a specific candidate. And then a parameter called candidate ID, which is the ID of the candidate to retrieve. This returns name, which is the candidate's name. And it returns vote count, which is the number of votes the candidate has received. Now we got a function getAllCandidates. Fully accessible, returns an unmodifiable view, specifically an array of candidates stored in temporary memory. And this is just going to return candidates. We'll add our documentation above the function. Returns all registered candidates. Specifically returns an array of candidate structures. I'm going to add one more function to this contract, function getWinner. This will determine the winning candidate based on vote count. Returns an unmodifiable view, specifically returns the name of the winner and the number of votes for that winner. First thing we need to do is ensure that at least one candidate exists. So we'll just check the length of the array of candidates. Make sure it's greater than 0. Ensure at least one candidate exists. Then we'll create two variables. One to store the max votes, set it initially to 0, and one to store the index of the winner, set that initially to 0. Then we're going to iterate through the candidates to find the one with the highest votes. We're going to create a for loop. We'll initialize I to 0. And then to enter the loop, the condition to be met as long as we haven't iterated through all the candidates. And then we'll increment I at the bottom of each iteration of the for loop. If the vote count for the given candidate at index I is greater than the currently stored max votes, let's reset max votes to be the total vote count for that candidate. And then store the index of that candidate in winner index. Eventually, we'll exit the for loop, and then we'll return the name of the winning candidate, as well as the vote count for the winning candidate. And of course, our documentation above the function. Description of the function determines the winner based on vote count. Returns winner name, which is the name of the winning candidate. And returns winner votes, which is the number of votes received by the winner. Now we're going to compile the contract. We're going to go to Solidity Compiler and click compile voting.sol. We're going to go to deploy and run transactions. For testing purposes, we're going to deploy to the default JavaScript virtual machine right here under environment. And under account, you can see here a bunch of test accounts that have been provided that we can use for testing and interacting with the application. We'll click deploy. Down here, I can see my deployed contract. If I expand this, I can see buttons that correspond with all the functions that I wrote. And now I can test the running of these functions given specific arguments. I'll start by registering some candidates given specific names. Let me register Alice. You can see the output in the console here. Let me register Tim. I'll register Sue. And let me register Greg. Then I'll test my getAllCandidates function. Here it returns an array of candidates, each one with a name and a count of their votes. They all have 0 for now. Let me vote for a candidate here, given their candidate ID, which is their index in the array of candidates. I'll vote for the candidate at index 0. Now let me get all the candidates, and I can see Alice has a vote of 1. Since each user can only vote once, let me go to another test account and vote again. This user will vote for the candidate at index 1. Now let me get all the candidates. I can see Tim's vote count has been updated. Let me switch users one more time. I'll have that user vote for the candidate at index 0. Get all candidates. Alice's vote count is now 2. And if I get the winner, I can see the winner is Alice with 2 total votes. Congratulations, Alice! Stay tuned for part 2 of this demo, where we're going to deploy and interact with the contract on the Ethereum testnet. We're also going to learn how to interact with the voting application via Web3, which is a Python library that allows developers to interact with the Ethereum blockchain.